So library management, this is one of the things that really has changed quite a bit in the last sort of 15, 20 years. If you remember, when we started the class, I had this magic 8-step plan for learning a language and framework. Step number 6 is understanding how the language and framework manage their libraries. So what libraries are available, and how do you manage the dependencies of your app on those libraries? And in some sense, to the extent that software reuse is kind of the holy grail, or one of the holy grails of software engineering, the emergence of libraries and library managers is almost a little bit of a success disaster. Modern applications, whether SaaS or otherwise, depend very heavily on libraries. If you all know about GitLab, which is emerging as sort of a GitHub alternative, that happens to be a Rails app, and it's open source. It depends on no fewer than 836 different gems. Remember that each gem in Ruby is basically a little library. Some gems are really trivial and do a very small amount of stuff. Some gems are quite complex, like the entire Rails framework is a gem. The Sinatra framework is a gem or a set of gems. And the library may also even depend in some cases on the language version. Sometimes if the language evolves enough that features in the language don't work the way they used to, some libraries that relied on those features may also have to change. So basically, we need to make sure that whenever we create an app, that app is always deployed along with any versions of libraries that it depends on, and if appropriate, also versions of the language that it may depend on. So library management is basically the question that says, how do you do that? So that when you create an app and it behaves a certain way when you've deployed it, if someone else tries to deploy it in a different environment, it should behave the same way. And a big part of that is getting the libraries to match up. So to do that, we have package management systems. If you've used Python, pip is a package manager. If you use JavaScript, especially if you use Node.js, npm. And in Ruby, as you've probably seen by now, bundler is the name of the package management system that we use. And the package management system really has two different goals, I guess, or roles. It records, from the point of view of the developer, what are the dependencies of the app on both libraries and specific library versions, as well as possibly versions of the language. And it makes some attempt to resolve those dependencies to come up with a collection of libraries with the proper versions that satisfy those dependencies, and that information travels as part of the app. So that whenever the app is deployed somewhere else, whoever is deploying it has complete information about what the app with its libraries looked like when you did your deployment, when you created the app. So you've probably already seen all the homeworks. Somewhere in the homework, usually in the top level, include a file called the gem file. And basically, this is where the developer specifies, you the developer, what are the minimal dependencies that would make my app work correctly. So for example, maybe I don't need a very specific version of some library, but I need a version that is between version X and version Y. Similarly for the language. The gem file, as we've now seen, gets run through this tool called bundle. That is the bundler gem. And it produces a file called gemfile.lock, which records the actual library versions. So basically, the difference is the gem file is you as the developer say, here are the constraints. Bundler tries to figure out a set of libraries with corresponding versions that satisfies those constraints. And generally speaking, it prefers the most recent versions of libraries that will work, but subject to the constraint that libraries may also depend on each other. So it actually has a pretty sophisticated graph traversal algorithm for trying to satisfy all the dependencies. And yes, in case you were going to ask, it is possible to accidentally specify dependencies in the gem file that cannot be satisfied. You might have two libraries that basically you've specified versions of those libraries that can never work with each other. And the bundler will just say, sorry, I can't build any gem file for you that satisfies all of those. So when you run bundle install, what is it exactly that's happening? Well, first of all, if the gem file has not changed since the last time you ran bundle install, and that's the case for the homeworks, right? Because you're checking out a code base where we have already provided a gem file. Basically, at that point, bundler just looks inside gemfile.lock to find out, OK, when this app was last run, when the dependencies were actually last computed, what is the actual set of libraries and versions that was used? And I will try to make sure that all of those are properly installed. And in some cases, they're already properly installed, and it runs really fast. And at the end, it says, dependencies are satisfied, so-and-so gems installed. Other times, it will have to go out to rubygems.org, which is where most libraries live, and download and install the proper gems from there. And as I said, sometimes libraries or gems can depend on other libraries or gems. So sometimes the process of installing a gem may first require installing other gems to satisfy its dependencies. So all of that stuff is what bundler is automating. On the other hand, if the gem file has changed since the last time the gemfile.lock was built, then bundler has to go through and rederive the dependency graph. Because if you added some new library requirement into the gem file since the last time bundler ran, it's possible that some existing versions of libraries in gemfile.lock might not work anymore. It's possible that you have added a new constraint that would require the actual library versions to shift around a little bit. So in that case, it basically tries to go back through the gem file, reconstruct the dependency graph, and then, based on that new information, reconstruct gemfile.lock and try to assemble all those libraries and install them in your app. So when we talk about versions of libraries or versions of the language, we can actually be a little more specific about what that means. And this is another case where there's an emerging standard that isn't actually written down as the rule of law anywhere, but has emerged as a sort of by consensus, this is how we talk about versions of things. And it is called semantic versioning. If you want to read all of the details, it has its own website. But as usual, I'm going to give you the sort of 10 or 20% of the concept that will give you the 80% of the understanding. You may never need to look at the website after this one slide. So you're welcome. Basically, it says that a library or a program or an interpreter will be labeled with a sort of three-part version number, usually separated by decimal points, X, Y, Z. And a change in Z means that a bug fix or a minor patch has been made. In other words, you should expect that there would be no problem of backward compatibility. If you're on version 2.3.1 and the library or the interpreter has moved to version 2.3.2, you're probably fine. It probably means that some bugs were fixed or minor changes were made. A change in the middle number is considered a minor version. And almost always what that means is new functionality has been added, but everything that used to work should still work. So again, a change in Y does not usually require any action from you. On the other hand, a change in X means this is a major version change, and things may break. Things may work differently in version 3 point whatever than in version 2 point whatever when the first digit changes. Okay, so not all software projects follow semantic versioning, but certainly the entire Rails ecosystem does. Most of the Python ecosystem does. It's becoming a fairly standard way to do it. And if you've seen, at least one person I saw posted on Piazza that when they were running their homework assignments, they were seeing these things that said deprecation warning. So what's going on there? A deprecation warning basically says you're using a feature or a behavior that in the next major version update is going to change. So you might be using Ruby 2.4.5, and a deprecation warning would be printed out if your code does something that in Ruby 3.x.x is all of a sudden going to change in a way that might actually break what you're doing. So the sort of rule of thumb is as you evolve your software projects, you may find yourself having to upgrade to later versions of libraries. Sometimes you have to do it even if your app hasn't changed. For example, you're using Heroku as a deployment platform. Like most deployment platforms, they don't support every single version of Ruby or Rails in the universe. They support a limited subset of versions. And at some point, as Rails advances and Ruby advances, they will phase out support for some of the older versions. For example, you cannot really deploy a project on Heroku anymore that uses version 1.x.y of the Ruby interpreter at all. So even if your app is not changing, just to allow your app to continue to run and interact with the rest of the cloud infrastructure, you may find yourself having to periodically upgrade. And in general, if you always upgrade to the last minor version, right? So before, let's say Rails, before it went to 5.0.0, what was the last major version, or what was the last major and minor version before 5.0.0? And I think if you look, it's something like 4.2.11 or 4.2.13, whatever it is, you can find out from the website. The first thing you do is upgrade all the way to that point, because that is the last possible point at which you will get the courtesy of deprecation warning saying, warning, in the next major version of Rails, all these things that you did in your app, these behaviors may change. So that is your opportunity to fix them. And usually the reason they're called deprecation warnings is they don't cause an error. Your code will still run, but every time it runs, you will get that nagging error saying you're doing something that is about to break. And it is worth your while to enter as a task to be done on your project to clear out deprecation warnings, because sooner or later, you probably will have to upgrade. And when that day comes, it'll be much less painful if you do not also have to deal with things breaking because you're using a feature that was previously deprecated. So that's sort of the high order bits of how semantic versioning works. And if you're seeing a deprecation warning, hopefully now you understand where it's coming from and at what point you should consider taking some action on it. Question, sir?
Just to clarify, is the deprecation warning then added retroactively after the major version changes happen?
So when does the deprecation warning actually get put in? Usually what happens is the team that maintains the software that is about to be versioned already has a plan for what's going to be in the next major version. So as soon as they determine, for example, that some feature is going to go into Ruby 3.0.0, whatever the very next release of Ruby 2.y.z will include a deprecation warning in anticipation of that. Right? And in fact, sometimes these .z releases exist just to do that. Even if the .z release doesn't fix a bug, it adds a deprecation warning for something that sooner or later is going to become obsolete. Yeah?
Before the next major version is released, what can you do to fix deprecation warnings?
So the question is, before the next major version is released, what can you do if you want to fix deprecation warnings? Let me Google that for you. So the answer really is, if the deprecation warning is hash initialization will work differently in Ruby 3, often the deprecation warning will actually have a URL where you can go to see what the discussion, usually on GitHub or wherever the project is, and you can actually see what the text is. But if it doesn't, just copy the deprecation warning and paste it into Google. Seriously, that's what I do. I don't know how we'd ever code without Google, by the way, or Stack Overflow. And with any luck, we'll have the founder of Stack Overflow here later in the semester to give a guest talk about how not to get flame roasted when you post on Stack Overflow. Other questions? All right, good. We're doing well. And lastly, I mentioned that sometimes, it's not as frequent, there are dependencies on the Ruby language version. Ruby is remarkably stable. It is only in its sort of third major version. The differences from Ruby 1 to 2 were substantial. I don't know how substantial they are from 2 to 3, but the assumption is some things could break. However, the Ruby community and the people who maintain the language interpreters have been very, very good about following semantic versioning, meaning that in theory, any Ruby 2.y.z should work just fine as long as it is not 1 point something and not 3 point something. In our homeworks, we have cautiously specified that it be greater than 2.2.0 just because the first couple of early versions of Ruby 2.0 actually did have some non-trivial bugs, and they sort of stabilized by 2.2. But in terms of compatibility and the way the language works, you should expect that as long as the first digit stays at 2, your version is probably fine. And if there are specific gems in your app that violate that assumption, you can expect that they will print out a deprecation warning when you try to run them. And I don't know how many of you have tried installing this. If you're actually working with multiple projects that require different Ruby language versions, and by different versions, again, really, we almost always mean that the major version number has changed. But RVM is a tool that allows you to maintain multiple totally separate Ruby installations. Each installation has its own set of gems. Each installation believes it is the only one, and you sort of globally switch at any given time which one you're using. So if you find, for example, during your class project, you may be starting work from a version of someone else's code that you might need to use RVM to install a different version of Ruby. So just so that you know it's out there. Some facility like this is kind of a necessary part of any programmer's workbench these days. So I'm telling you what the tools are in the Ruby and Rails ecosystem, but the concepts will map over to any other language or framework that you would ever use. OK, any questions about semantic versioning or gem files or anything like that? Now you know.
Are we going to have to worry about like pessimistic and optimistic version constraints?
Pessimistic and optimistic version constraints. Give me an example of what you mean.
You know, like the tilde equal sign. Like it's like when you have like a require like a gem file, it's like you need this version, like be exactly this version, or like anything greater.
Right. So basically, the question is, if I may paraphrase it, bundler actually gives you a lot of different ways to specify version constraints. You can either say, I need absolutely this very specific version of a library, or it doesn't work. Or you can be a little more permissive and say any version of the library sort of within this range would work. And the question is sort of how much do we have to worry about things like that? There's probably no magic answer. I can tell you that for my part, I try to at least constrain my libraries to certainly the major version and maybe a minor version. The risk you run into is someone else will pick up your app and they won't be able to modify it because they will want to introduce some additional library, and that additional library won't work with the exact version of some library that you picked. Even though in principle, it probably would be OK for you to be flexible on yours. So that's why there's a gem file and a gemfile.lock. The gemfile.lock is here's what actually is known to work. These specific versions absolutely will work. The gem file is supposed to say, these are the versions that could work, and if you need to recompute the dependency graph, it's OK to do so. So the onus is a little bit on you as a developer when you decide to use a library. Learn a little about the library so that when you enter it in your gem file, you can put in some reasonably intelligent constraints. But there's sort of no magic answer. Software is like a shark. If it stops swimming, it dies. I just came up with that. Isn't that brilliant? But seriously, you never sort of leave a piece of software alone, right? It's because the software, especially if it's software as a service, is embedded in an environment that is also always changing. So you sort of have to pay attention to it on an ongoing basis.